hemispherical tank is made up of an iron sheet. Okay. Let's say instead of a tank, let's talk about a bowl. Okay, you know, a soup bowl, right? A soup bowl, if you may. So a soup, why I'm taking soup bowl is because it is a little thicker than your regular glass bowls. Okay. So it is in the shape of a hemisphere and it is a little thick. There's some thickness. Now, that material that you are using to make that bowl, you need to find the volume of that material, meaning how much material have you used to make that bowl. That is the question here. Okay. Did you understand the question?
Yes, ma'am.
Okay. So in this case, it is a hemispherical tank. Okay. And that tank, it is made up of iron. Now, if you just think about anything, maybe even in geography, you might be learning this, that metals are used to make certain materials, uh, certain products, right? Like for example, there's a particular ratio of different types of metals that make steel, for example. So when you're going to make, let's say you're going to make something or made of iron, or let's say if you want to make a gold sculpture, a statue, then what do? They have a mold of that shape and they pour, let's say if you want to make let's say a mug, okay, or a bowl, a hemispherical bowl if you want to make. So they have a wooden or something, or some other material. They have a mold and this will be in the shape of a hemisphere and they will pour iron into it. So you will get a solid hemisphere. You will get a solid hemisphere. So that iron that you are pouring into this, the molten iron, the molten metal that you are pouring onto this, it has some volume, right? So that is a volume we're talking about. But in this case, this is not a solid object. It is a hollow object, meaning that it is a bowl or it is a tank. The iron part of it is only covering some portion. It's not completely covering the entire hemisphere. It's not inside the hemisphere. It's just a part of the hemisphere, right? So the iron part of it. So what do? Is they have another, when they pour some metal, they pour some metal over here. Okay, maybe till here. They pour some metal, and then quickly they will put another hemispherical shape. So when they put that hemispherical shape, this metal will rise up and it will come off till here. So what you will have is a hemispherical metal tank or a metal bowl. Okay, or any metal it could be, that metal bowl. So you want to know the volume of the metal that you poured into this. That basically means the amount of metal that you used to make this particular object. How can we find the amount of metal used to make this object? You can simply find the, now for this, to understand how to find this, what we did was we tried to see, we tried to understand it in a two-dimensional figure. For example, if you have a picture frame, okay, you have a wooden picture frame, the entire thing is not made of wood, only the boundary is made of wood, only the boundary is made of wood, only this frame part is made of wood, right? So if you want to find the surface area of this boundary, what will you do? You have done such questions in your, in your previous classes, that in such cases we used to find the area of the bigger square and we used to subtract the area of the smaller square from that. So area of big square minus area of small square. or rectangle, whatever this is. Okay. So the same thing we are going to do to find the area of, sorry, the volume of this material, because over here also we were finding the volume of the material that was used to make this frame, which was, in that case, it was wood. But in this case, the material we are using is iron. We want to find the volume of iron used to make it. So the volume of iron used to make it is going to be volume of the bigger hemisphere minus volume of smaller hemisphere. Till here, did you understand?
Yes.
Okay. So that is what we have done. Volume of the bigger hemisphere, we have found it. We had the radius, the outer radius was 1 meter plus 1 centimeter, which is 1.01 meters. 1.01 meters. Or if you want to find that in centimeter, it is 101 centimeters. Okay, so we have the outer radius, so we found the volume of outer hemisphere. Then we have the inner radius, so we found the volume of inner hemisphere. Then to find the volume of the metal, the volume of the iron, we did volume of outer hemisphere minus volume of inner hemisphere, and then from that point onward it was just the calculation. Understood?
Yes, ma'am. Okay, understood.
Okay, so let's come to the seventh one. Find the volume of a sphere whose surface area is 154 centimeter square. So it's a sphere. Surface area is 154 centimeter square. Find the volume. You have to find the volume. So, well, how do we find the volume? Volume we know is 4 by 3. For sphere, it is 4 by 3 pi r cube. But we don't know r. So maybe we can find out r from the surface area. So what we'll do here first is we will write surface area is given as 154 centimeter square, right? This is given. But then what's the volume of, what's the formula of surface area? It is, what do you remember? What is the formula of surface area of a sphere? Anyone? It is very simple. Surface area of a sphere is 4 times the surface area of a circle. So 4 into pi r square is equal to 154. So r square is equal to 154 by 4 pi, which is 154 by 4 into 22 divided by 7. So 11 twos are and 11 14s are. 2 sevens are. So here we have 7 into 7 by 4. Yeah, 4, which is basically 49 by 4. So your r square is 49 by 4. So r becomes root over of 49 by 4, which is, what is root 49? It is 7. And root 4 is 2. So 7 by 2 centimeters, because the unit given to us was centimeters. So this is your r. Always remember, put your final answer, whether it is a final answer or whatever you have found. You have found out something, right? The result of something, that you always put in a box. Okay, now this is the first step. The first step was to find the radius. The second step, because in the question they're not asking you to find radius, the final answer you will have when you have found the volume, because that is what they were asking you to find. Find the volume of the sphere. So volume, we know the formula for volume. 4 by 3 pi r cube. We know R. Now from here it is just calculation. Okay, so if you want, you can leave your answer like this itself, or you can calculate it further. You can find it in decimals. Okay, let me know when you're done so that we may move ahead. Okay, let's move ahead now. Eighth question. A dome of a building is in the form of a hemisphere. Okay, so you can imagine there's a dome of a building which is in the shape of a hemisphere. From inside, so it is a hemisphere, right? Okay. From inside, it was whitewashed at the cost of. Now, they're telling us the cost of. This is a question in which you have to think carefully. You have to really apply your brain in such questions because it is not a direct question. Okay. Direct question means they will tell you the radius or the diameter. Radius or the diameter will be given, and they will ask you to find the volume. They will ask you to find the surface area. That is a direct question. That is very easy. Nothing to be done over there except for calculation. But in such a question, you need to think about it. So from inside was whitewash at the cost of this. So cost of whitewashing. Whitewashing means what? Area. Remember, whitewashing will be done on some area. So cost of whitewashing is rupees 4989.6. If the cost of whitewashing is rupees 20 per square meters, per square meter means per 1 meter square is rupees 20. Find this and this. Find what and what? Surface area and volume of air inside the dome. Okay, see. So cost of whitewashing. Okay, if I tell you, if I forget about this dome right now, if I tell you that I went to the market and I bought a lot of chocolates. Okay. I went to the market and I bought a lot of chocolates. And I paid rupees 2000 in total for all the chocolates. Acha, and I'm telling you one more thing, that I bought each chocolate for one chocolate. I paid rupees 20. Can you tell me how many chocolates I bought from this? I bought some chocolates. I'm not telling you how many, some chocolates. And I paid rupees 2000 for all of them in total. And I'm also giving you an additional piece of information that each chocolate cost me rupees 20. So how many did I buy in total? What do we have to do here? What do we have to do here? Okay, see, if you guys are not going to respond, then no problem. I will just move on with the question. Fine. So cost of whitewashing is given and cost per meter square is given. So from this we can say, let's see, cost and meter square. So cost is rupees 4989.6. Let's say for x meter square. We don't know how many meter square, so let's call it x. And cost is rupees 20 for 1 meter square. So there's this thing we do, which is, this is called the unitary method. We put an x, and whatever is on the opposite sides of the x, we multiply them together. And the rest of them, we multiply them together. Okay. So this is going to be x is equal to whatever is on the same side, whatever is connected by the same line, which is 4989.6 into 1 by whatever is left out, which is 20. So into 1, I'm not going to write. This is 4989.6 by 2, 9 to 10. So 2 twos are 4, 2 fours are 8, 2 nines are 18, again 2 fours are 8, point 2 eights are 16. So this final answer, your x is 249.48 because this is divided by 10. So therefore area that was whitewashed is equal to 249.48 meter square. Okay. Now, so that means surface area of dome. Why internal? Because we were talking about internal surface area only. From inside, it was whitewashed, not from outside. So internal surface area of the dome is, see, till now we have not applied any formula in this question. The formula will come now. This is the first part of the question. We will put it in a box. Now comes the formula, volume of the air inside the dome. So how do we find the volume? So you see, you need to think about it like this. To find the volume, and volume of what? This is a hemisphere. So we need to find volume of hemisphere. We know that volume of hemisphere is how much? 2 by 3 pi r cube, but we don't know r. So r we can find if we write the formula of surface area. So surface area is 249.48, and surface area of hemisphere is how much? The curved surface area. Curved surface area of hemisphere is 3 pi r square, right? Remember, pi r square circle, 2 pi r square. Oh, sorry. Curved surface area of hemisphere, 3 pi r square. Total surface area of hemisphere, and 4 pi r square surface area of a sphere. Okay. So 2 pi r square equals 249.48. So from here we can find r square. I'm just going to remove the decimal for a while. Okay, let's not confuse you guys. Now I removed the dot, the decimal. So 24948. Let's see if it is divisible by 11. And since you guys are in ninth grade, I hope that you already know to check how to check the divisibility of 11. And 2 plus 9 plus 8 is 19. And 4 plus 4 is 8. And 19 minus 8 is 11. So yes, this is divisible by 11. So 11 twos are, and then 11 twos are 22. 11 twos are 22. And 6 are 66. 11 eights are 88. Is this divisible by 4? Yes. So 4 fives are 20. 4 6 are 24. 4 sevens are 28. So now we have so it's 39.69. R square is 39.69. Now we gotta find out R. R is going to be root over of 39.69. Now let's do one thing. R square is 5, no, 3969 by 100. So R is going to be root of 3969 divided by 100. What is the root of 3969?
40.
40. Root of 3969 bache. Let's calculate it using the prime factorization method. Okay, sorry. Yeah,
63.
yeah, it's going to be 63. So 3969, 3 1 3 2 3 3 it's gonna go, yeah, 3 fours are 3 fours are 3 ones are 3 ones are 3 fours are 12, 3 sevens are 21, 3 fours are 12, 3 nines are 27, and then 7 sevens are 49. So we have 7 into 3 into 3, which is 7 into 9, which is 63. So R equals 63 upon 10, which is 6.3. So 6.3 meters. This is the radius of the hemispherical dome. Okay, but we have to find the volume of the air inside the dome. So Volume of air inside the dome. Volume of a hemisphere is 2 by 3 pi r cube. So we find the volume. 2 by 3 into 22 by 7 into r cube. 63 by 10 into 6 point. Yeah, 6.3 into 6.3. 7 nines are 3 threes are. So we have 4. No, 132 into 6.3 ka square. We have just found out what is 6.3 ka square, and that is 39.69. So now we just calculate the remaining part. Meter cube. Okay, this is going to be your answer. So let's take a look at this question again. How did we do it? Hemisphere, the cost of whitewash, the total cost that uh, that was incurred for whitewashing was this much, and the rate of whitewashing is given. So from that, we can figure out how much surface area was whitewashed. So for x meter square, the cost was this much. For 1 meter square, it was this much. So we can find out x. So x is basically the area that was whitewashed. So that means we have found the surface area of the dome. From there, we applied the formula of surface area and we found out. So here we applied the formula of surface area and we found out the value of r from here. R came out to be this much. Now from here we found out the volume by again using the formula of hemisphere. So volume of hemisphere. Okay. So that's the 8th question. Let's do the 9th one. Okay, I hope you guys are done. So the 9th one. Okay. So in the 9th one, we have 27 solid iron spheres, each of radius r and surface area s. So some radius they have. We don't know what it is. It could be 5, 6, 7, 9, 10, 12, anything. Okay. We have given it a number r. Okay. R is basically any number. So all of them are of the same radius, 27 solid spheres. They are each of the same radius and some surface area. They are melted to form a sphere. So these smaller spheres, they are melted, and from that molten iron, we made a whole new sphere. And obviously, it's going to be bigger than all of them combined, right? So it's bigger than all of them, and the new radius is r dash and the new surface area is s dash, we are supposed to find the ratio of r and r dash and the ratio of s and s dash. So first of all, what is going to be different in these? So let's say there are 27 small spheres. There are 27 small spheres of the same radius. Each of these, like, so all of them together, they are melted and formed, they are converted into, they're transformed into a big sphere. So each of these has radius r, and this one is going to be radius r dash. So obviously we can see that r and r dash are not the same, they are different. And we can also see that the surface area is going to be different. The surface area of one small sphere is s, then the surface area of the big sphere is going to be s dash, and obviously it's going to be different. But there's one thing that's going to be the same, and that is if you take the volume of all of these things combined, when you add up the volumes of all of these small 27 spheres, that is going to be equal to the volume of this sphere, because volume means amount of something. So amount of metal, like it's the same amount of metal that's being melted to form the new sphere. So the volume is going to be the same. That is one thing that we can use in this question. And then we know that these are 27 spheres. So 27 solid iron spheres, each of radius r. So first of all, volume of one small sphere is going to be how much? 4 by 3 pi r cube, because the radius of small sphere is r. So volume of 27 small spheres is how much? 27 into this thing, right? 27 into this thing, which is 3 9 are 27. So 36 pi r cube. Now, as it turns out, volume of 27 small spheres, or you can say volume of one big sphere of radius r dash, is going to be equal to volume of 27 small spheres. So volume of the one big sphere is how much? 4 by 3 pi r dash cube. Okay, because the radius is r dash this time, is equal to volume of 27 small spheres, which is 36 pi r cube. So now we have a relation between r dash and r. So pi get cancelled. Cube and cube will not get cancelled yet, okay? Don't cancel them. And so we take r dash cubed is equal to 36 r cube into 3 by 4. So 3 by 4 will go to the other side, it will become reciprocal. Okay. Now 36 into 3. This can be written as 4 into 9 into 3, or instead of that, let's just do this. 4 9s are 36, right? 4 9s are 36. So we have 9 into 3 is how much? 27. 27 r cube. So r dash cube is equal to 27 r cube. So r dash is cube root of, just a minute. Yeah, r dash is cube root of this entire thing, or we can say it like this. 27 can be written as 3 cube. This is r cube. So this is what? 3r whole cube. So your r dash cube is 3r whole cube. That means r dash is actually equal to 3r. This is, we have found this. Okay. Now, that was the first part of the question. Now, the second part of the question is find the ratio of their surface areas. S by S dash. If they say ratio of S and S dash, that means you have to do S by S dash. So that is equal to S surface area of the big sphere is 4 pi r. Sorry, the small sphere 4 pi r, and the, sorry, 4 pi r square, because it's surface area. Surface area means square wala thing has to be there. And S dash is 4 pi r dash square. 4 pi get cancelled. R is r itself. R dash can be written as 3r. So r square and 3r whole square. So that is r square by 9r square, which is equal to 1 by 9. So the ratio of S by S dash is 1 by 9. Please note this down. Okay. All right. Next question. The 10th question. A capsule of medicine is in the shape of a sphere. Okay. Let's say this is a capsule of medicine in the shape of a sphere. The diameter is 3.5 millimeters. That means radius has to be 3.5 by 2 millimeters. And just to get rid of the decimal, I am going to write 35 by 20. You don't have to do this necessarily, but this is just to get rid of the decimal. How much medicine is needed to fill this capsule? How much medicine is needed means, and they're saying to fill it means it covers the capsule from inside. It fills it up. right? It fills the capsule from inside. So that means they're talking about the volume of medicine required is equal to 4 by 3 pi r cube, which is equal to 4 by 3 into 22 by 7 into 35 by 20 into, I'm just gonna write 3.5 by 2. Okay, 7 5 the, and that's it. 22 into 5 is 110 into, oh, wait a minute, 55 by 3 into 3.5 into 3.5, which is equal to 22.45, you can say 46 millimeter cube. Okay, that's the answer. This was very straightforward. Okay, so this completes, with this we complete the exercise, but let's do a few more questions. Okay, the volumes of two spheres. I'm writing the extra questions. Please, you also have to write these questions in your notebook so that you don't lose the questions. Okay, the volumes of two spheres are in the ratio 64 is to 27. Find the ratio of the surface areas. Okay, so the question is given, volume of two spheres are in, okay, let's first of all, let's say that those two spheres, let R1 be radius, or we can say let R1 and R2 be the radii of first sphere and second sphere respectively. V1 by V2 means volume of the first one by volume of the second one equals, what is the formula? Volume of a sphere is 4 by 3 pi r1 cube by 4 by 3 pi r2 cube. Now here 4 by 3 pi gets cancelled, and we are left with r1 by r2 whole cube. And this is given to us as 64 is to 27. 64 by 27. Now think about it. 64 is the cube of what? 64 is the cube of 4. Yeah. 4 into 4 into 4 is 64. And 27 is the cube of 3. So this can be written as 4 by 3 whole cube. So r1 by r2 whole cube is 4 by 3 whole cube. So we can say r1 by r2 equals 4 by 3. So that is the ratio between r1 and r2. But we have to find the ratio of their surface areas. Write it till here. Okay. Now we have to find the ratio of their surface areas. So let's say surface area 1 by surface area 2. This is going to be how much? Surface area of a sphere is 4 pi r square. So 4 pi r1 square by 4 pi r2 square. 4 pi cancelled. Okay, so we are left with r1 by r2 whole squared. Now we know r1 and r2. So that is 4 by 3 whole. We don't know r1 and r2, but we know r1 by r2. We know their ratio. So r1 by r2 is 4 by 3. So that's that. And so this becomes equal to 4 square 16, 3 square 9. So that is your S1 by S2. Please note this down. Okay, let's come to another question. Okay, the water for a factory is stored in a hemispherical tank whose internal diameter is 14 meters. The tank contains 50 kiloliters of water. Water is pumped into the tank to fill mm, huh, to fill it to its capacity. Calculate the volume of water pumped into the tank. Okay, so let's try to understand what is happening here. They are saying that the water for a factory is stored in a hemispherical tank whose internal diameter is so and so. So there is a hemispherical tank. Hmm, okay, there's a hemispherical tank. Diameter is 14. So the internal diameter is 14 meters. So the radius is going to be 14 ka half is 7 meters. Now we have been told that the tank contains 50 kiloliter of water. So it already has some amount of water in it. Some water is already there in it. Oops. Some water is already there in it. Okay. So let's say some water. Wait a minute. Some water is already present in the tank. We have to find water. So some water is already present in the tank. After this, some extra water is pumped into the tank. Some more water is pumped into the tank so that the tank gets completely filled. So what they are saying is the water that is already present is 50 kiloliters. That is some volume. Some volume is given. They are filling the tank some more. They are filling the tank some more so that it can fill to its capacity. So they are asking how much volume of water, what is the volume of water that has been pumped into the tank. So the tank already contained some water. How much more water have you pumped into the tank? So this is very similar to one of the previous questions that we have done. Okay, in this what you have to do, you have to find, now listen to this carefully. First you have to find the volume, to overall volume, the actual total volume or capacity of the hemispherical tank. Okay, and then you subtract from that the volume of water that is already present. Then you will get volume of additional water pumped. Okay, water that has been pumped into it to fill it to its top. Okay, additional water pumped into it. So first of all, volume of the tank is how much? Volume of the tank, this part. Volume of tank is 2 by 3 pi r cube, which is 2 by 3 into 22 by 7 into 7 into 7 into 7. 718.6 meter cube. Now here is a slight tricky part. This volume is in meter cube, but the volume of water that is already present, this is given in kiloliters. Yes. So volume of the tank, the total capacity of the tank is this much. Now volume of water already present is equal to 50 kiloliters given in the question, and we know that 1 meter cube is equal to 1 kiloliter. We discussed this in the very first class. 1 meter cube is equal to 1 kiloliter. So 50 kiloliter means 50 meter cube. Yes. So this is the volume of water that is already present. So we just subtract them. So therefore, volume of water pumped into it is equal to 718.67 minus 50, which is 668.67 meter cube. Please note this down. Okay. So that's it for the class. If you don't have any doubts, you may leave. If there are any doubts, please ask.